Hey guys, so in this video we're going to take a look at experimental techniques. So these are just some of the skills or some knowledge that you need to know about how experiments in the lab are done. So we're going to start with measuring tools. How do we measure different things in the lab? So of course we need to know how to measure time, and I think we already know that we just have to use a stopwatch. So a stopwatch is something that it's a watch which if you press, it's going to start running in seconds or minutes depending on how you have set it up. Then there's also a scale, a weighing scale, which is used to measure mass. But these are just they're not difficult, but the ones that get complicated are instruments that are used to measure volume. So we're going to concentrate on that. We're going to look at instruments that are used to measure volumes because there are different types of instruments which are used depending on the situation. So we're going to see what type of situation is this instrument used. And after we do that, we're going to take a look at how gases are collected after experiments. So when you are doing experiments, when you mix one or more things, they are going to react, and at times, depending on the type of reaction, you can end up having a gas. So how do you collect that gas? So we're going to take a look at 3 different ways of collecting a gas. So just connect what we're learning here from what we have been learning. We learned about nature of matter because we are studying the chemical composition of matter, which is chemistry. So we learned about nature of matter. Then we looked at different sets of matter can mix, form solutions. Then now we are here. Of course, the main topic is separation techniques, which is going to look at how we can separate things that are mixed. But this one is basically aimed at empowering us with the knowledge or skills that can be used to make sure that we do experiments appropriately. Because for us to study these chemical compositions of matter, we need to do experiments. So that's what we're going to learn here. What tools do we what tools are needed for us to do our experiments the way they should be done. So we're going to start with the first apparatus, which is called the beaker. So the beaker is used to measure volumes of liquids approximately according to the graduated marks on the apparatus. So the keywords here, volumes of liquids. And of course, we're going to start out to measure most of them that we're studying, which is measuring volume. We're going to start measuring volumes of liquids or solutions, not solids, because solids are straightforward. You can use a meter rule to measure the volume of a solid. You just get the length, the breadth, and the height. Then you can just use the formula volume is equal to L times B times H and the likes. So what we're concentrating on is just volume of liquids and maybe gases. So a beaker is used to measure volumes of liquids approximately. So a beaker doesn't give you an accurate value. When you are doing measurements, sometimes it's difficult to get the exact value. Let's say you're using a meter rule. You want to measure the length of your pencil. So you just discover that it's when you put your pencil from the 0 mark, then the upper part of the pencil is on maybe between 10 centimeters and 11 centimeters. How can you tell the number between the two if you don't have something to guide you? So we approximate. So that's how the beaker is. It also approximates. It doesn't give you an actual value because of the graduated marks on the apparatus. This is the beaker. So if you look at this beaker, here are the graduated marks here. So if you pour in some liquids in the beaker, and maybe the liquid, the surface of the liquid is here, how do you tell what value this is? Of course, you have to approximate. So that's what it meant, approximately, according to the graduated marks on the apparatus. So this is the beaker and how it's used, and you have to keep in mind that it approximates. You can't get the actual value. The accuracy is not that good. Then the next one is called a volumetric flask. So this one is used to accurately, unlike the beaker which just approximates, this one gives you an accurate value. So this is used to accurately measure fixed volumes of liquids when solutions of particular concentrations need to be prepared. So other than just measuring liquids like a beaker, this one is used to measure fixed volumes of liquids accurately, especially when solutions of particular concentration need to be prepared. So what does this mean? When you are doing an experiment and you want to make a solution of particular concentration might mean you compare the amount of solids you put and the amount of liquid that is in that solution. For example, if you are preparing sugared water, or zig as it is called, the amount of sugar that you put determines the concentration. So the one that is sweeter than the other, it means you have put more sugar as compared to the solvent. So that one is more concentrated. So if you need to prepare a solution of particular concentration, or if they say we want a solution to have this amount of to have this concentration, which means the amount of sugar that has to be put in that sugared water or ziggy as compared to the amount of water should be this. So if you know the exact concentration that you need, you have to use a volumetric flask. So that's what this means, particular concentration. So if you want to prepare something of concentration or of particular concentration, you use a volumetric flask. So these are the keywords that you should not forget: accurately, fixed volumes of liquids, and particular concentration. So this is how a volumetric flask looks like. So there are different types of volumetric flasks depending on in short, they have different volumes. This one is 10 milliliters. There are some which are 25 milliliters, just like that. So depending on the amount of solution, the amount of solvent that you want to prepare for that concentration, you choose. For example, if you want to prepare a solution that needs 10 milliliters of a solvent, you can use this one. But if it needs 25 milliliters of a solvent, you have to use another one which is calibrated, or which is written 25 milliliters here. So that's how a volumetric flask is. So the difference between the beaker and the volumetric flask is the beaker, it's approximately, then the volumetric flask is accurate, and the volumetric flask is used when you want to prepare a solution of a particular concentration. The other apparatus that is used is the pipette. I hope that's the correct pronunciation, pipette. So this one is used to accurately measure volumes of liquids when a fixed volume of solution is needed for an experiment. Again, just like the volumetric flask, this one is used to accurately measure volumes of liquids when a fixed volume of a solution is needed for an experiment. So if, for example, this one is particular concentration or non-concentration, but this one is fixed volume of solutions. Let me first explain how a pipette works, and maybe I show you how it looks. So this is how it looks. So what you do with this pipette is if you want to prepare a solution, which means a solvent and a solute has to be mixed, or maybe it can be two miscible liquids. So if you want to transfer one liquid from where it is to where you want to prepare the solution, because you have to mix, so you have two things that you have to mix. So if you want to transfer from one container to another, you use this pipette. So what you do is you just sink this lower part into the liquid, then you press here. When you press here, or when you squeeze this part here, what will happen is this pipette is going to suck the liquid. Then once you do that, you can go you can go into where you want to mix, and you can do the same, and the liquid will come out. So use this part to control the sucking and dispensing. So that's how a pipette works. So now, how does this relate to this? So it is used to accurately measure volumes of liquids when a fixed volume of solution is needed. So when you want to prepare a solution that has a fixed volume, you don't want to mess with the volume, so use a pipette. Then the other one is a Buret. So a Buret is used to accurately measure to the nearest 0.1 centimeter cubed, which means the smallest reading you can get with a Buret is 0.1 centimeter cubed. You can't get anything less than 0.1 centimeter cubed. So a Buret is used to accurately measure to the nearest 0.1 centimeter cubed volumes of liquids which are used up in an experiment. So what does this mean? So what this means is, let me just show you how a Buret looks like. So this is a Buret. So when you are doing an experiment, what you do is, you can use this to lock here so that there is nothing that moves between this part and this part. So you can put, I don't know, or whatever experiment you are doing, whatever reaction you want. You can put a beaker, for example, if you're using a beaker to do the reaction, or anything, or it can be it can be anything, or a petri dish. You can put it here, so long as that's where you want your reaction to occur. So one of the reactants in the reaction can be here. So what you want maybe is to add another reactant. So what you do is you pour your reactant in here. Of course, it has to be a liquid because that's what we are studying here. So let's say you pour up to here. So the surface of the reactant of one of the reactant has reached here. So the idea is you use this to make sure that you allow some of the reactant to pass and mix with whatever is down here for the reaction to happen. Then as you do that, as the other reactant is flowing down, you can lock it again so that you see the results. If you don't get your results, you open again so that more of it goes down, and again you lock it, you wait. When you get the desired results, then you can go and look at how much has been used. How? Maybe if initially it was here, like I said, and at the end of the reaction, when you have achieved your results, the surface is here, it means 10 has been used. So you just subtract this number from this number. So that's the amount of liquid that has been used. So that's how to use a Buret. And so the keywords are accurately to this volumes of liquid which are used up in an experiment. It means that difference, that volume, has been used up in this experiment. So that's how a Buret works, or how it is used. Then we've got a measuring cylinder. So a measuring cylinder is used to measure volumes of liquids with some accuracy. By some accuracy, it means not that accurate as compared to these others. So this is to the nearest centimeter cubed. Nearest centimeter cubed, it means 1 centimeter cubed. It can't go below 1 centimeter cubed, meaning that the Buret is more accurate as compared to the measuring cylinder. So measuring cylinder is used to measure volumes of liquid with some accuracy according to the graduated marks on the apparatus. So the keywords here are, of course, some accuracy, and of course graduated marks, which are used to determine accuracy. So this is how a measuring cylinder looks like. So again, when you want to do an experiment, if you want to have a certain liquid that you are going to use in the experiment, you just pour that liquid here. So as you are pouring, you check the reading here. So if you want, for example, 40, sorry for that, if you want, for example, 40, so when it says 40, then you know that you have the desired volume. So you can now transfer this to there are people are disturbing, sorry. So you can transfer this to whatever solution that wherever you want to take it. But the point is, it is used to measure volumes of liquids with some accuracy according to the graduated marks on the apparatus. Then we've got the syringe. So this is used to measure small volumes of liquids with some accuracy according to the graduated marks on the apparatus. So this is the keyword here is small volumes, again to some accuracy, just like the measuring cylinder. The only difference is the syringe is used to measure small volumes, and the measuring cylinder is used to measure any volume that that is within the limit. Of course, you cannot measure maybe 100 liters, you can't. But of course, the syringe is just small volumes. A syringe is the normal syringe that we know, this one. So this is used to measure small volumes of liquids with some accuracy. Then finally, we have the gas syringe, which is also a syringe, but of course used to accurately measure volumes of gases produced in experiments according to the graduated marks on the apparatus. So this is used to measure, if a gas has been produced in an experiment, you want to measure it, you use the gas syringe. And of course, the gas syringe is something like this. You might think that it is the same as the normal syringe, but there is a difference. Let us take a look at schematic drawings or simplistic drawings that are going to show us the difference. So this is the normal syringe and this is the gas syringe. So just from the way they look, you should be able to tell the difference between the gas syringe and the normal syringe. This one is usually used for liquids, like I said, and this one is for gases, which means once the gas has been collected, you don't want it to escape. So this one is secured at all points. There are no spaces where the gas can escape. Even if it escapes here, it will be trapped this side. But this one, it can escape here. So that's the difference between the normal syringe and the gas syringe. These are just for your understanding, not maybe you'll be tested. No, this is just for your understanding, that this part of the difference between the gas syringe and the syringe. What is important is to know what what apparatus can be used in a given situation. For example, if you have been asked to measure the amount of gas that is produced in an experiment, what instrument can you use? Of course, it is a gas syringe. If you have been asked what instrument can you use to measure the amount of liquid or the amount of reactants that are used up in a reaction, what are you going to use? What could be the answer? The answer is, of course, the Buret, because it's the one that is used to measure accurately the volumes of liquid which are used up in an experiment. So depending on the situation, you should be able to tell what instrument you can use. Finally, we'll finish this part with methods of collecting gases in an experiment. So there are three methods that are used to collect gases in an experiment. The first one is called displacement of water. And this one is used to collect gases which are not very soluble in water, such as oxygen and hydrogen. So the key word here is soluble. Not very soluble. Meaning that this gas does not dissolve in water. And this is not hard to remember, because this is how the displacement of water is. This is how the apparatus of displacement of water is arranged. So your reaction will be happening here, or whatever that produces the gas will be this side. So that gas will be collected here, and it will go through this pipe. And when it reaches here, it will come out. And once it comes out, if it is soluble, it will mix with water. But if it is not soluble, it will form bubbles, of course, which will rise up and your gas will be collected here. So this is the displacement of water. The second method that can be used, or that is used, is downward delivery of a gas. So this is used to collect gases which are denser than air, such as carbon dioxide, hydrogen, chloride, and chlorine. So these three gases are just examples: carbon dioxide, hydrogen, chloride, and chlorine. The most important thing to know is they are all denser than air. So the fact that they are denser than air, how does it help in collecting the gas? So this is the way the apparatus is arranged. So you have whatever is producing the gas here. So your gas will come here, then it will come here. Then when it is here, if it is less dense than air, which means if it is not as heavy as air, so that's though that's a wrong word. So if it is denser, which means it sinks in air, it cannot rise up here. If it is light or less dense, it could go up, but because it is denser, so it will stay here. So it means you have collected your gas. You can even remove this. You have your gas here and here on top. So that's what downward delivery is. The last one is upward delivery. So this is used to collect gases which are less dense than air, such as ammonia and hydrogen. So what does it mean, less dense than air? It means it's lighter than air, which means when it floats in air, when you release it where there's air, it will go up because it is less dense. So this is the arrangement. So your gas will come here, then it will go up. Once it's here, since it's less dense, it will just be here. It can't go down. If it is denser, it could go down, but it's not dense, so it will just be here. You have collected your gas. So that's the upward delivery of a gas, and this marks the end of this part of the topic. Hope you enjoyed. Otherwise, happy solving.